The overall goal of this experiment is to describe the use of micro-thermocouples to estimate local temperature gradients at condensed fuel surfaces for steady laminar boundary layer diffusion flames.
This method can help answer key questions in the fire science field, such as exploring the dynamic relationship between a combustible condensed fuel surface and gas phase flames in laminar and turbulent boundary layers. The main advantage of this technique is that it can be used to accurately measure local mass burning rates in steady laminar boundary layer diffusion flames. Demonstrating this procedure will be Colin Miller and Wei Tong. Both are PhD students in mechanical engineering.
For liquid fuel experiments, prepare a fuel wick from porous non-combustible material, such as alkaline earth silicate wool. Bake the wick for about 20 minutes using a diffusion flame from a propane torch. This will burn all the organic binders inside the wick. Next, apply a high-temperature adhesive to aluminum foil and secure the aluminum foil to the wick. The top must remain clean. For solid fuel experiments, prepare a sheet of the solid fuel with the same dimensions as the wick. To mount the solid fuel, cut a long slot into a sheet of ceramic fiber insulation board, or use a porous non-combustible material sealed with high-temperature matte black paint. For either free convection or forced flow experiments, position a digital SLR camera where it can view the central axis.